So today we're going to take today to look at the normal curve and a normal distribution. So the first thing you see here are a variety of graphs, and they make this bell shape. It's often called the bell curve as well. And what this is, I like this second one here. If we made histograms, and let's take a look at the pink one, of all the height of women, and we roughly outline it here, it makes this nice curve that's called the bell curve or the normal curve here. Men do the same. This is another one with IQ distributions. Now what happens here is it's this normal curve, and what happens is the average falls right in the middle. So that is your mean. So in this case, the mean IQ is 100. And then last year you guys talked about standard deviation, which tells us how spread out the data is. The smaller the number, the closer together all our data points, and the more spread out, like the further our data is away from each other. Well, within one standard deviation on either side of the mean, so you can, sometimes it's denoted with this sigma. So one on either side is 68% of all the data. And these are rounded. Your textbook might use like 68.3. You'll see different values. But we're going to use this 68, 95, and within 3 will be 99. So within 2 of the mean is 95% of the data. And with 3, so within this third one here, is 99% of the data. And I think it might even be 99.7, but we'll just use 99. So here's this normal curve right here. So again, if we were to label it right in the center, that is always your mean. So then on one standard deviation away, and we'll use that, and then we'll mark out 2 standard deviations and 3 standard deviations. And you saw those numbers up here, so it was divided into those percentages. But again, within 1 is 68%. Within 2, whoa, that did not go to the second one there, is 95%. And within 3 is 99% of the data. Now, it doesn't always fall within those. The number of standard deviations is called your z-score. And I'm going to use a little bit of notation here. Z-score is your value minus the mean divided by the standard deviation. So for example, let's say you had if we went back up here, let's say your IQ score of 120. So if we wanted to see how far away this was, we would say 120 minus our mean of 100. And we can see our standard deviation is, let's see, it looks like it's 15. So now we have 20 divided by 15. So that is 1.25. So it's 1.25 standard deviations away. And if we look at this, that makes sense. 1 is here. So it's a little bit more, so it's 1.25. But it doesn't always match up on that 1, 2, or 3. You could go the other way too. Let's say we wanted to have an IQ score of 60. So to figure out how far this is, 120 minus 60 divided by 15. So let's see. Oh, not one. Whoops, sorry, messed this up. I thought something was wrong there. Our score goes first. So 60 minus 100 divided by 15. So 60 minus 100, so we have negative 40 over 15. So let's see, it goes in there twice. So this is negative 2. That'd be 30 and 10/15. So negative 2 and 2/3. So, and we can see that up here. That makes sense because 60, 1, 2 and it's in between 2 and 3, so it's negative 2 2/3. So we're going to take a look at a couple problems in there here. Jenny scored 600 in the critical reasoning section of this ACT. How good of scores is this? I feel we're missing some information here. Bummer. All right, well, I guess we can't answer this one, but so her score is 600. We don't know where the mean is though. So that's not going to help us. So we'll come back to this one later. I'll see if I can find the information. So this next one, the ACT is an exam used by college and universities to evaluate scores. In recent year, this mean score was 20.8 and the standard deviation was 4.8. The test scores of 4 selected students are this. Find the z-scores. So again, it's the score minus the mean divided by the standard deviation. So let's see, the first one of 18. So we would do 18 minus 20.8 divided by 4.8. And I'll leave you to see what that is, but it's obviously going to be negative. It's below. If we did 32, we could do 32 minus 20.8 divided by 4.8. Then our last one, if we did 14, we got 14 minus 20.8 divided by 4.8. So we can see they're all going to be either lower or higher than the mean, because our mean, if we were to draw the curve for this, our mean is right in the middle at 20.8. All right, hopefully there's enough information for this one. A truck loaded with cartons of eggs that weigh an average of 2 pounds, each with a standard deviation of 0.1. A histogram of those weights looks very much like a normal distribution. What percent of cartons have less than 2.1 pounds? So if we were to draw this, here's our mean is 2. So here is our first standard deviation, so 1 standard deviation. And our standard deviation is 0.1, so this would be 1.9, 2.1. We go out to 2 on either side. 2.2, 1.8. And then our third, 1.7. And our third here, 2.3. So what percent of cartons weigh less than 2.1 pounds? So we want to know this percent. Well, there's quite a few different ways we could figure this out. I mean, it's more than half. So we know that from here on down is 50% of the data. And we know within 1 is 68. So half of that would be 34%. So we could do 50 plus 34 equals 84% of the data. What percentage weigh less than 1.8? So we're looking at, it's going to get some messy shading here. Just right down here. So that's within 2 standard deviations. Well, let's see. What do we know within 2 is? So within 2 is 95% of the data. So this half of the middle, what's half of 95 would be 42.5%. And we know over here is 50%. So we could do 100 minus 50 minus 42.5. And let's see, so that would give us 50 minus, would that be 7.5%? No, that can't be right. Something happened there. It's totally not 42.5. That's why. What was I thinking? That is 47.5. So if we subtract 47.5, that's going to give us 2.5. That got really messy. Sorry there. Now that's not the only way to think about this one. As I was doing this, I realized, so we have our mean, and we had 2 standard deviations on each side. And so we know that this area in the middle was 95%. So that means on the outside, either ends has to be 5%. So that side would have to be 2.5, and this side would have to be 2.5 because it's symmetrical. So the last one, what weighs more than 1.9? So let's see, here's our mean. 1.9 is just 1 out. So we have, once again, we have this 50% of the data. Then we have that little chunk. Well, that's within 1. So we know within 1 is 68. So that means this is 34 plus 50. And we have 84%. So since we didn't have that first one, let's take a look at one from our review. Let's see if we can find this here. This one here. So we have a STEM plot of the IQ cohort of 74 7th grade students. This distribution is very close to normal with a mean of 111 and a standard deviation of 11. So between what values do IQ scores of the middle 95.5 of all rural? So this is where I said some use 95.5, we use 95. So let's draw our picture here. So this is 111. And if we count standard deviations out, so this would be 122, 133, 144. Going backwards, we would have 100, 89, 78. Okay, and we want 95.5, so that's 2 standard deviations. So 2 standard deviations would be right there. So between 89 and 133. The next one here, what percent of IQ scores for all rural 7th graders are greater than 100? Does this compare with the percent in our sample? So let's see here, greater than 100. So that would be that whole area. Well, we know it's more than half. So we know that from here on over is 50%. So then what's that number? This is 1 standard deviation, so that's 68%. So half of that is 34. So we have 50 plus 34 is 84%. How does it compare with the population? Well, let's see. There were 74 students. So how many had a score of above 100? Well, that would be all of these. It might be easier to count below. So 1, 2, 3, 4, 5, 6, 7, 8, 10. So let's see, 74 minus 10. So there's 64. So is that close to 64 out of 78? And you could type that into your calculator and see. What percent of IQ scores have 144 or higher? So this curve again, 144 was 3 standard deviations out. So that's way over here. Now, if we remember that this is symmetric, within 3 we said was 99%. So that leaves 1% to be split among this. So both of those must be 0.5. So it'd be 0.5%. I mean, and are there any? No, because that is such a small number. So there weren't any in our sample.